Yes, I'm quite ready. So do you want to do open the talk, or how do you do it with your user group? Are you doing any introductions, or should I just start?
Yeah, well, we're going to keep things short. Okay, so this is our first virtual meetup that we're doing. And thankfully, Michael agreed to help us. And he's going to be talking about GraphQL and Blazor. Okay, but that's not my talk, so I'll leave it to him. Just we'll be using Slido for questions. If you have, the code is Blazor. So I'll post it here in the chat and also on YouTube. And if you have any difficulties with the stream, just let us know in the comments. Michael, we can start.
Hi guys, I'm Michael Staib. I'm a Microsoft MVP, and I'm also the author of the Hot Chocolate GraphQL platform, or one of the authors. There are, in the meantime, a lot of people contributing. And today I would like to talk to you about building real-time applications with GraphQL and Blazor. So it's my first time actually to do an online talk, so it's quite a different experience. So with Blazor, Microsoft, for the first time in years, gives us .NET developers actually a viable solution to build cool applications that in .NET that run in the browser. And that is quite an opportunity for us .NET developers, because we don't have to be or have to learn another language just to build our applications. And yeah, let's get started with that. So first, because I know a lot of .NET developers still don't know GraphQL, let's first dive into what GraphQL is and why I think GraphQL can supercharge Blazor. So GraphQL is not another OData or something like that. It is actually developed by, or was developed by Facebook and was invented in 2012. And Facebook actually started work on GraphQL because they, back in the days, had quite a few challenges with their mobile applications. And a lot of people back then criticized Facebook heavily about their mobile application, because they used a lot of battery life, or they burned through your data plan in minutes. Well, that's a bit exaggerated, but on top of that, they were quite sluggish. And Facebook initially set out to build mobile applications because they were getting quite popular, and they tried to do that with standard web technologies. So they built their mobile applications like they built their website with data fetching technologies like, for instance, REST. And when the Facebook engineers started looking into the issues that their mobile applications had, they discovered that by just starting their mobile applications, they already did hundreds of requests to their backend. And then actually on a mobile application is very bad, because you might have not a good reception. You might be on 3G instead of LTE, and aggregating a lot of data with a lot of connections is quite bad. So it is, if you think about it, we can quite easily think what might have happened. Like when you started your Facebook app, it might have started to fetch your profile. Maybe it went to graph.facebook.com/me endpoint and fetched your user. Actually, for the application, we would have just needed to fetch the username and the user ID and maybe an image, but we get all what the me endpoint in this case offered. And the thing here is with REST, or what the issue was with REST that Facebook had, is that REST has the concept about resources and fixed data structures. So the consumption of the REST API is already defined by the backend developer. That means that the backend developer has to make assumptions on how you consume the API. And if we go forward in this example, maybe we fetched just our me endpoint here and fetched our user profile. Then we actually also want to display the feed. That means we have to maybe grab the user ID and then take that user ID and pass it along into a next request on our API. So maybe our feed API looks like this, has one parameter, the user ID. We pass the user ID in and fetch that feed. So that's our second request already. And now we get a lot of data, our newsfeed here with a lot of stories that we have. And the second issue that we run into is that we don't have the like count that we have in Facebook because it might be aggregated on a different API. And we have some other data like the comments that user do and the user who maybe wrote this story and stuff like that. So we again maybe just grab all the IDs that we find here and fetch the next request for us. Maybe we fetch the comments. And we actually have to fetch multiple comments now in parallel because we have multiple stories there. And then again, we get all the comment data and maybe are missing some other things like maybe the user. So you can already see that this led the Facebook app to have some kind of a data waterfall, which is not easy to parallelize because we actually need always data from the previous request. And this is actually bad because we are now chaining the data requests and it takes longer and longer for our app to actually get what we want. So Facebook, back then, it was actually 3 engineers that came up with the idea to reverse the responsibility. Because actually it is much better when you could fetch all of the data that we need for our application, maybe to start up or for a certain component, that we could fetch that in one go. So Facebook came up with the idea that we should actually have just one endpoint where we can fetch all the data that we need. And we should be able to specify in the request what we actually want. So with GraphQL, I can define GraphQL query that actually specifies what data I need or what data I want. So in this example, I basically put all the data I wanted for my application startup in one GraphQL query. So all the requests that I showed you in the beginning are now aggregated in one query. So basically, I fetched the current user. From the current user, I just wanted the name. And I also wanted from the current user the feed and the messages. And by just looking at this graph, it's very human readable. So it's how we humans think about data. We want to drill into data. We want to have those relations, but we don't want to resolve those relations ourselves. We want to explore data more naturally. And with GraphQL, if I send in such a request, I also get a very corresponding result, meaning in GraphQL, query and response closely align, and that is one of the key features in GraphQL. When you get started with GraphQL, a good mental picture is that you are sending in an empty JSON graph and the server just fills it up. It is not like that, and we will see that in the demos that I have for you. Okay, so with GraphQL, now we have the ability to fetch everything from one endpoint. We just have one endpoint where we query to, and that makes it much less complicated. Like with REST, we need to know all those endpoints where we fetch stuff from, and we need to parallelize our fetches quite a bit. Okay. And in GraphQL, I can fetch everything in one request. Like I showed you, I can define as the consumer of the API what data I actually need, and then send it to the server and get my data back that I requested. And that means with GraphQL, I have no over or under fetching. And overfetching is always when I basically get data that I don't need. So because the REST service or the gRPC service, they defined data structure, and I just need two properties of those. So in that sense, I'm overfetching. And underfetching is every time I have to issue another request because I didn't get enough information. And GraphQL is built on a strong type system. And all of these makes GraphQL very predictable to use. We will drill into these a bit further later. Okay, that's enough about GraphQL. Just to get you all into why GraphQL is cool. Let's head on into Blazor and what Blazor is about. So with Blazor, I said in the beginning, we as .NET engineers, for the first time in years, have a solution to run applications in the browser. We had that before. We had Silverlight, but this time Microsoft put real .NET into the browser. There's no plugin involved. With Blazor, Microsoft started to work on a mono runtime that actually runs on WebAssembly. And WebAssembly is no proprietary plugin or something like that, like Flash or Silverlight were. It actually is built into all the browsers. And it is not .NET specific. So WebAssembly, we could compile C++ or Rust or any other language into WebAssembly and run those in the browser. So with the mono runtime in the browser, we basically have .NET Core in our browser. And that means we have less JavaScript and more .NET what we can put there. So with a full runtime, we actually can reuse a lot of our code. Back in the days when we had Silverlight, it was quite frustrating because we had this kind of a castrated API, we would say, where a lot of was missing. But with the mono runtime there, we now can basically use our full set of .NET APIs. That means we could take dependency injection from ASP.NET, or we could take the HTTP client factory and all those things. We can just use these packages and put them in our solution. And the best thing is everything here runs near native performance. And this is quite good when you are building .NET application and they don't feel like those sluggish Silverlight applications back in the day. Okay, and with WebAssembly, as I said, it's an open standard, and all around Blazor is actually open source. That means you can head to the ASP.NET Core browser, file an issue. You can look at the code. You can do contributions. Everything is open like the rest of .NET. Okay, let's have a look how that actually works. So the Blazor runtime, or how it actually works, everything, is that you write your standard C# code in your project, and we will see that in a demo in a minute. And then you have Razor views. We know Razor views. We know how Razor works. Back from the MVC days, they made it a lot better now, but we actually are quite quickly familiar with how it works. So everything of that is compiled into a .NET assembly, which runs on a mono runtime in a WebAssembly VM. So it natively runs in the browser. And that looks often funny because when you look in Chrome, what is loaded, you see a lot of DLLs, and it's quite a different view of when you're going on a website that has just JavaScript in there. So the actual .NET, the actual Razor application that runs in the browser works against a shadow domain. The shadow domain is like a copy of the domain with which Blazor interacts, because actually WebAssembly applications cannot manipulate the actual browser domain. So what Microsoft built for that is like some JavaScript. So you see when you are running Blazor applications, you see a mono.js and Blazor.js, and those JavaScript files basically update the actual DOM whenever there are changes committed to the shadow DOM, and they do that very efficiently in batches. And also the other way around, when we click on something on a DOM object, maybe we click on a button, then these events are relayed back to the shadow domain, and then .NET event is triggered. That's why I said there is less JavaScript, because at the moment we have still to use this JavaScript router that interconnects between the WebAssembly VM and the actual DOM. But it's a lot less. I think you actually never need to use JavaScript if you don't want. But the cool thing here is also, if there is a cool JavaScript component out there, like you want to use maybe the Monaco editor to do some cool coding stuff, you can just wrap it in a Blazor component and use it, although it's built with JavaScript. Okay, so let's go further and look at, so Blazor at the moment, there is already, right, I have one issue. So Blazor at the moment, there is already a released version of Blazor out there. It's a Blazor for the server side. And I'm not talking about that. That's a stable version. That's a Blazor that basically runs in your backend and updates the DOM over SignalR. It's super stable. It's a super platform. But I think where it really shines Blazor is when we run in the browser with WebAssembly. That's the future. And at the moment, this is just in preview. Yesterday, they released a new preview. I'm using still the old one because I didn't want to botch my demos. And with my demos, we actually cannot debug yet. But that doesn't matter. But there are a lot of other experiments around Blazor. Like Microsoft at the moment is dabbling their feet in building a Blazor Electron integration. And they're even looking further into ditching Electron because it's quite memory hungry, uses a lot of stuff that we don't need, like node runtime and stuff like that. So they are actually experimenting with running Blazor in native web views of the operating systems. And then we are talking about very small footprints and a lot less memory usage than you would have with Blazor, that you would have with Electron. But Microsoft is even going further with Blazor, and they are experimenting with mobile bindings. Basically, you can then do XAML with Blazor. So you can see that Microsoft is putting a lot of eggs in its Blazor basket. So you can reuse all the knowledge that you acquired with Blazor for server, Blazor or WebAssembly to build a multitude of UI applications. So that's enough talking, I think. So as I said, everything is preview. So for all the faint-hearted here, we are doing now some preview demos and expect things to explode. And I hope you can see crashing demos. Okay, so when I thought about real-time applications, I actually thought, how can we do a talk about that? And the first thing that came to my mind is to build something like Slack clone, where you actually can interact with data. You can fetch data, like doing GraphQL queries. You can do mutations when you write a message. And you actually need GraphQL subscriptions to do real-time data when messages are coming in. So our demo will not look as nice as the actual Slack client, but it let's try to build a nice application here. So before we head deep into the code, let's first run our application and just have a look or get a feeling of how this will look like. Let me just get this zoom view smaller here. Okay. So I just typed in .NET run to get my application up and running, and it's at the moment running on port 5000. I can, oh, I need another browser, another window. I can just call that in Chrome, and my Blazor application already came up. And let's just do one thing here. Let's look at the developer tools. Refresh that. And if we look at the networks tab, we can see that there are a lot of DLLs downloading to our browser. And that's what I meant earlier with that it looks kind of funny. We don't have any HTML files yet here. We have like Microsoft Extensions Primitives DLL or the System Runtime Compiler Services. So it looks like this is a real .NET application. Okay, so our Slack clone has on the left side people's list. And our first task is to just display all the people that we can talk to in our chat app here. And let's close that app. And I walk you through that little example here, and then we build that in. So when we look at the Blazor app and just open it, we can already see that we have something that is called a program CS. And that's very familiar because every console application in .NET has that. And like the console application, we also have a main function or a main method that starts here. On top of that, we have like something called the WebAssembly host builder, and that is very like ASP.NET Core applications are built. So you have a builder that sets up your system, and you basically have a kind of a console application around it. But in contrast to ASP.NET Core, we don't have a startup CS here, but we have something that is a root component, and that is called app. And if we go to that root component, we can see it's basically an empty page here, but has another component in there. And that's our actual main component. So let's open components here. We can see, again, there's our main component, and go into that and see that there is a people's list in that component. And that's actually the people list that we want to build now. And there is a concept in SPA applications around components, like we have smart components or stateful components. And these components is where all the magic is happening. So we will put all the state logic and data fetching logic in our smart component, which is in this case main. And then we have kind of dumb components or stateless components, and they are quite good to reuse. So people list, for instance, is a dumb or stateless component. And if we look at the people list, we can see that it is at the moment just HTML. We have a lot of HTML here. We have the placeholder that was the nice icons that we saw in the left bar, but there's nothing else. Then we have a placeholder, and the placeholder is also just HTML. And then we have a person item, and that's actually a component that we need to change in a minute, which should display the person at one point. This component we want to load into the people list and display the person. So, but before we can fetch anything, we actually need some data. We need to fetch some data from somewhere. So let's set up our project to run GraphQL. So let me clear that out here. And I'm working personally on a Mac with Visual Studio Code. For Visual Studio for Windows, we have a much more UI workflow. So you basically can click everything what I'm doing now with the console. So the first thing I need to set up my project with Strawberry Shake. That is our .NET GraphQL client. And just to show you, I already prepared this project, so we already have the strawberry shake package in here. But I still have to set up my project to run with my endpoint. So what I'm going to do is say .NET GraphQL init, and now I need a URL for my GraphQL endpoint, which I got here. Let's just put that in there. And then I give my client also a name, because we are building a chat app. I call it chat, and just run that. So what's happening now is that our CLI tool that is integrated with the package is now grabbing the GraphQL schema and downloading it. And that's important, because GraphQL is strongly typed, and we are actually compiling every GraphQL query that we are putting in this application against this local schema. So we have our local GraphQL schema here, and we have a configuration file which is called berry.json, which holds information about where we fetch this API, where we fetch this schema from. In order to now write a GraphQL query, we need to add another file. I call it now queries.graphql. You can name it however you want. We actually hooked ourselves into the MS Build compile process, and we pick up all the GraphQL files that you have and analyze them if they are query files, if they are schema extension files or schema files. Okay, so the next thing is we need to build a GraphQL query. The best thing to do that is to use one of basically our GraphQL IDE that we are also building open source in our project, which is called Banana Cake Pop. We have a lot of funny names around our components. And we need to build our first query here. So what we want to do is basically fetching the people for our peoples list. So in GraphQL, a query starts with the keyword query. So we just type in query, and then we actually could go on type the actual query. But wait a minute, with the GraphQL IDE, I actually can first explore what data is actually available. So I can click here on the schema explorer and can already see that our query type, our query root type, offers a lot of fields where I can fetch data from. I can see that there is a me field, for instance, which is the currently logged in user. And the currently logged in user maybe has an email address, or maybe can explore some friends. So I could fetch some friends, and I can basically drill into my data. So I'm already exploring what my schema is like before I did the first request. Okay, but actually what I want is just a people list. So I want the people that I can chat with. And from that, we need some data. So I close that, and let's just write here people. And then we saw in the initial slide that GraphQL, you can drill into the data. So I can write, I want people. And then I can say, actually, I need the nodes. This nodes field is actually because we implemented the relay paging specification here. So that's why this extra layer is there. But now I can actually fetch the fields that I need from my person. So I need a name, and I actually, for my list, it would be good to have a date when this person last was online, just to show an indicator if this person is online or not. And I now could actually fire that query up and get already some data back. Let me make that bigger. Zoom that a bit out. Okay, so I can see that my people here, and there are Michael Staib, which is myself. There's Jose, a friend of mine, and some other people that have registered there. And I can see it's not ordered correctly. So with Hot Chocolate, we have this awesome filtering and ordering middleware that basically rewrite that into any database. So I could ask for this result set to be ordered by the name. Let's do that. Fire that up again, and I have an ordered result set. Okay, but in order to use that with Strawberry Shake, we actually need to give our operation here a name. So we call this operation get people. And then we can just copy that over to our queries GraphQL and put that in. And now we just need to compile our project. In Visual Studio for Windows, actually, the moment you type in something into a GraphQL file, we are compiling in the backend. So in Visual Studio for Windows, we are doing design time compiling. And you can see that now there popped up a new folder. It is called generated. And we actually now have some, for instance, a person interface here, which actually just has a name and a last seen. So basically what we defined in our query. And now I can go back to my components. And I said we are starting with our person item component. And we need to build some properties into here, because this is a dumb component. I said, so basically we have the data flow of the smart components are pushing data down the dumb component tree, you could say, and this way updating the data of the components. So let's put in here some code so that we can put that in. So we basically need a property that we can address. So we put in a property that is called person. Oh, person. No, that is of the type person, sorry. Okay, little hiccup. And this property actually is not yet usable. We need to add an attribute that is called parameter. And now this property becomes the parameter in our tag, in our Blazor tag. And I can show you that in a minute. But we are not done here yet. I already put in some placeholders. And in order to bind these to my property, I just put an at in front of this. And now that's actually basically C# code here. I can jump to my user property here by just clicking clicking the key F12. So let me put that here too. So now this component is bound. It basically gets a user in, and we are binding, we are outputting the username in this div and the last seen in that span. Okay, so let's now get to the people list. And the people list is where we want to use this component. But actually, this people list gets in a people connection. That is our paging type. So let's put that people. Yeah, let's put in a parameter here that gets this people connection from our data graph and can display that. And in order to in order to have a nice loading experience, we actually want to tell our component also when it is loading. So let's put in another property that is indicating if our component is loading. So, okay, so now we basically, every time it's loading is true, our component is loading. And if it's loading, we want to basically display our placeholders that we already have in here. So we just put a little if clause here, is loading. Let's do that here, add that here. And in the other case, we actually want to display our data. So we basically then iterate over the people connection here and putting in new person items. And now you can see the parameter that or the property that I declared in my person item now became actually an attribute on my tag. And the same way, these two properties will now become a tag on my people list here. So we need to feed in actually now the people connection here or the person connection and the is loading indicator. So let's just create in our main component a little field that is called is loading, and one little field that actually has the person connection It's nullable, and it's called people. Okay, the next thing is when our component is initialized, we have to do something. So let's actually, when our component is built, it's actually loading. Let's set it to true. And now we actually need our client. We have our GraphQL client already generated, but we need to use it. And I said in the beginning, we can use things like dependency injection. So in Blazor, I can use something like this inject directive here in order to inject a chat client. And that is basically what was generated. And I can call that chat client. Okay. And now I can actually use that in my initialization method here by saying, okay, I have a result. And I actually await get people. And I want the result to be ensured that there are no errors. GraphQL actually can do partial results. So in an actual real life application, I would handle errors less strict and maybe reuse data that is there and maybe refetch things that had an error. Okay, but for the demo purpose, this is okay. We now need to set our people field here, and we actually say result data. That is actually our GraphQL data that is available. And from that data, we want the people. Okay, and last but not least, I set the is loading to false. And now I need to notify my component tree that I have changed data that is relevant to my components. So I can do a state has changed here, and then Blazor will update my components or bind this data to my components. Okay, but I still have not bound the data. So let's fill in our attributes here. So I'm binding people to people and is loading to is loading. Okay, we are actually ready with our first application. We have built everything in, but we are still missing something. We injected something that we didn't register with our dependency injection. And with Blazor, we can do that with our builder. We have here the standard ASP.NET Core dependency injection framework, and we can just say add chat client, because our generator already generated for you all the bindings for the dependency injection. And last but not least, I need a way to connect to my backend. So I actually need to add something else there, and that is called the HTTP client factory. So I can say I need an HTTP client because that is my way I want to do the transport in that case. And I actually can say I need a HTTP client that is called a chat client. And this chat client should be bound, should be configured like the following. And HTTP client is actually a great way to use the client, because you can put things like poly in to handle retry logic and stuff like that. So if you want to know more about HTTP client factory, Steve Gordon has a lot of blog posts around that. So I would suggest get to Steve Gordon's webpage. Okay, so what we need for our demo case is just to set the base address. So we say new URI here, and we need the URL. I already have a snippet here. So we are putting in a URL to our backend, and then we need an actual token to communicate with our backend. So we are putting in the authorization token here. Was it? Let's put that here. it's a bearer token, and I actually prepared that as a snippet. Sorry. Okay, so that's all in. We can compile our application. I hope it runs now. Oh no, I already saw there's a comma missing. Okay, we compile it. Okay, everything is there. Almost done. Okay, so our application is now compiled, and we just can basically do .NET run here. It will go up again. Sorry. Let's open our browser again. No, it was on 5,000. It's loading, and boom, we have some data here. Okay, I messed up the formatting maybe a bit, but just to get our first fetch. It was very easy to get GraphQL in there and to do our first fetch. So let's get back to our slides. It is alive. We did our first GraphQL Blazor integration. Awesome. I hope everybody is psyched. But actually, it was nothing. It was just a simple fetch, and we want to do much more. So let's get into a schematics here. So what we've built so far is we built a people list here, and we fetched our items there. But now we are doing the awesome stuff. Now we're doing real-time stuff. And for that, we basically built the main content area here. And what I want to build here is a header where we have some basic information about the user. Then we need some message bubbles here. So we need more components for the message. And we need a footer where we can type in our messages. Okay, so for that, let's swap gears away with this example. And let's do a second example, which I prepared a little bit more. Okay, let's start that. Okay, what we have here now is essentially the same application that we had before. So we have our dependency injection configured here like before. We already have our queries GraphQL, which has some data. It has some more data in here. And we actually have our people components. But we now also have chat components. And the chat components, basically, I showed you that in the schematics. We have a header, we have a footer, we have the chat message, and we have actually the message list where the stuff is aggregated. And I already prepared our main component so that we now actually bound a few events here. So every time you click on a person, there is an event raised, and we get that person on which we clicked. And then we actually need to fetch data for that person. So we need to fetch the messages for the person on which we clicked. So we need another fetch method that just gets the initial messages. So the second thing is that when we click on a send message button in our UI, we need to actually send out the message. And last but not least, we need like a real-time data stream that gives us the messages that are coming in. And we have later a live site which you can all go on and send me messages directly into my debugger. But first, let's get to it. So our GraphQL query that we have here, there, is actually not anymore sufficient for what we want to do. So let's go back to Banana Cakepop, our GraphQL IDE, and modify that query a little bit more. So let me just slide that in so we have some more space. So for now, we just have one query. So the second query I said is we need something to fetch the initial messages that we have with someone that we want to chat with. So we could start writing a new query here that is called get messages. And this get messages maybe should fetch a specific person that we are talking to by email. And then we actually want from that message, from that person, the messages that we have written to them. So we actually can ask for the messages. And then again, we have a paging API here. That's why the notes field is here. Then we actually can fetch maybe the ID of the message. We could get the direction. Okay, we have a recipient here. That's interesting. And the recipient actually is a person. And we have a person up here. Okay, so let's grab just some fields that we might need up here. We format that and go on. Okay, now we have something that is called a sender. And that is, again, a person. So let's copy this field. And you can already see that this feels kind of wrong. But let's go on for a minute. And next thing, we are heading here and grabbing some text. So the text of the message and maybe the date when it's sent. So the way we build this API feels kind of wrong. We are using the person of the API here quite often, and we could actually reuse that. So in GraphQL, we have a construct that is called fragments, and fragments are reusable data shapes. So we could create a fragment that is called person, and which can be applied on a person object. And we could just feed in our fields here. And then instead of declaring our fields up here, we could just refer to this data shape and just say, okay, this is our person. But this actually doesn't fit in here. So actually what we need for that, for our second fetch is, or for our second query, is another fragment that we might call participant. And that is also applied on a person and actually fetches only these three fields. We format that. But actually, we could use the fragment in a fragment, so we can get rid of these and just say, okay, a person is also a participant, and so it has the fields that participant has. And now we can get rid of these fields because they are actually now participants. And we can get rid of these, so it's now much cleaner. But we can go even further because we can cut this out and create a new fragment that we call message, which is applied on a message. And our message basically for our application looks like this. Second, I'm referring here to message. Now I can reformat. And so basically I now have components here defined, reusable components. And now I have the basic get message fetch here. I need another action actually to write a message. So this, in order to change data on your server, we have to use something called a mutation. So with a mutation, we can mutate our server state. So we need a mutation that is called send message, that sends a message into our system. So in this case, we have a send message mutation, which has an input, and we actually need recipient email, and let's use a placeholder here for a second, and we have a text. And then we can actually, again, because we get a message back, the message object that we produce with this mutation, we get that back. So we are able, after the mutation is executed, to query the changed state of the server. So we are now getting a message back, and we can again reuse this nice message shape here. So how can we do actually those inputs here? We need inputs for this, and here for the text. And GraphQL has a concept that we can basically specify variables on our operations. So I can say I have an email here, and the email is a string that cannot be null. And I want to use that email. And what I actually have now is an operation with some arguments in there. And I can do the same. Let me copy that down here. I can actually do the same here and use the email address there. And then I need a second argument here. That is the actual message. Can also not be null, and I put that in here. We make more space here. So I now have two new operations, still not real time, but I can now fetch the initial messages and send new messages in. Okay, let's grab that for a minute and then put that in our application. So we are putting that in here. So at the moment, my project actually doesn't compile because we need to fix up the components in a minute, but still. So the object model is now already generated, and I have a person interface now here, which implements participant. So when I use fragments in GraphQL, Strawberry Shake actually interprets this as an inheritance. So in this case, interfaces that implement interfaces. So that means a person is also a participant, and the participant also has just the shapes that I need. So I can actually, from my GraphQL query, control how my objects in .NET will be generated and produced. Okay, so let's build that actually in. Let's head over to our main component again and create this little application so that it runs correctly. So the first thing here on click person is that we need our chat client. So let's grab that. I don't want to type too much. And then we actually say, when you click on a person, we got the message. We want the messages. We can actually copy that too, because we don't want any errors in this case. And the next thing we need is we actually need to store somewhere our data. So I mean, we just put in immutable list here, and this immutable list actually should use a message, and this type is also generated. And in the beginning, our immutable list is just always empty. And you will see in a minute why I'm using an immutable list here. Okay, and then we actually can put in our component, our actual message list component. So I prepared that. And this message list component binds actually to nicely to the message list here. And actually, I forgot one thing. We also need the recipient to which we are writing. So let's also add a person here, which is our recipient. It's nullable. Okay, now it looks better. So we actually put in our message list here, which binds nicely to our recipient and to our messages. So when we click on a person in our person list, we will now fetch the messages that are associated to that person. For that, we are grabbing from the person the email, feeding that into our operation here, and fetching that data. And then we actually set the recipient to the person, and the messages are just an immutable list, create range with the initial messages that we grabbed from the server, person by email, and notes. Sorry. Yeah. No. That messages. Sorry. And then notes. Kind of long at the moment. Okay. So After we have updated our two things here, our two fields, we can again call state has changed. So our component tree is updated. We basically have the messages. But let's not stop there. Just let's put in the send as well to then run the application and look what it's like. So the second thing is when we click on the send button to write a message, to send a message, we actually can use our check line again. We now have a send message async here, and we want to send to the recipient that we stored in our field, and sends a text that our message here has passed. So that's basically we're passing the message to our GraphQL server. We are ensuring that there are no errors. And then we are getting actually back the result here. And so we are getting a message back. So we are taking our message list, sorry. And we are just adding that message that we get back from the server. So data, and then send message, the message should work. Okay, and in this case, we also update the server state has changed. So let's run that for a second. And then we will put the last part in. Coming up, I hope there's no error. This time we open a new one. So all the thing is on port 5000. Our application crashes. That is all I wanted because we are short in time. But let's just check it out. So I have the old Blazor preview here, so we don't have all the fancy, fancy stuff. So debugging with the preview until now looked like that. There was a way to get it started differently, but actually it didn't work for myself. Okay, what I've done, I messed up here, is actually I didn't have the right token in here, and I hadn't the correct URL to my server here. I still had a local URL here, and I'm not running the server. So what we are putting in here is actually the correct URL. And let's also just quickly grab our token, put it here, and then kill our endpoint, run it again, and hope that it now turns out to be better. Chat application, see if it's already on, not yet. Loading, awesome. So we have now our people list like before. It's now more nicely formatted. I could click here on my friend Jose, and I get the messages that I write with Jose all the time. No, kidding. Test messages. And I also could write some of my own message. So I could write here, hello, Jose, send that in. And I actually have a new message here. But it's kind of not a nice experience yet, because messages that somebody else would write me, I would have to refresh. So let's put in the last part of my demo and then get real-time data working. And you will, I think, see that it's super easy to build real-time applications with GraphQL. Because we are going back to our GraphQL IDE here, and we are adding one more thing. So the third operation in GraphQL is called subscription. And subscriptions are kind of our event streaming. So I can say that I have a subscription that maybe is called on message received. And that subscription actually uses a field that is called on message received. And in this instance, it doesn't need any arguments because the server knows who I am from my token. But I can specify here, I can actually see that on message received is actually a message. So I can reuse my message shape here, can say, okay, that's actually a message. So use the message fragment. And also, that's another thing here with GraphQL. I actually don't have to take the names of the fields that the server offers me. I could say, okay, what comes back here is actually a message, and on message received is not a good name in my C# class, so I want it to be renamed. So that's an alias. So let's do that. So you just saw, I'm just putting here maybe 5 lines of code into my GraphQL query. I copy that over to my queries GraphQL. Let's paste it in. Let's compile. And yeah, there are some errors, I think, but that's okay. Let's see that in a sec. Should be all right. Okay. So now we go back to our component, and I already have this prepared. I'm just putting in a, let's see, begin message received. I prepared a little snippet, so I don't have to type that up don't waste more time. So it's called on message received. I have a different name here. So what it does is basically, this is an async function. So I have a normal sync function that basically starts a task. And so my task runs basically in a loop here for as long as I can loop. So what I do in here is basically I'm using my chat client, and I'm calling this on message received function. And what I get back is I get back a message stream. It's called a response stream in GraphQL. And I can now use this new await for each syntax, because response stream is actually an async enumerable. So I'm for eaching now over the stream until there are no more messages. And I'm checking that each result that I get from the server has no errors. And if it has, if a recipient is set in our component, I'm accepting this result and adding this to our immutable list here. So I'm mutating this list whenever a message comes in. So this implementation is a little bit wrong, because I'm not filtering if this is actually for the chat I want, but this is actually by design. If I wanted to cancel the stream, there is something with async streams. I could pass in a cancellation token. So I could say with cancellation, and then I could cancel the stream. Also, the server, like in my GraphQL server, I could also cancel the stream when the stream is finished or when I want it to be gone. So what I'm doing here in my initialize lifetime function is now to call this begin receive message, begin receive messages. And now actually my function would start running, connect to the server, and start receiving messages. But that actually does not work yet, because we just using HTTP clients here. And GraphQL subscriptions by default work over WebSockets. So what we built on top of that, because WebSockets are actually really hard to configure, you have to write a lot of code to do like retrying connections and when they abort and fix those stuff. So we built something like the HTTP client factory. So I can now say add services and say I need a WebSockets client here. And I actually could copy this configuration code, put this down here. Okay, it doesn't really align up that pretty, but I could fix that and say, okay, base URI is actually URI, and the URL for WebSockets is actually VSS for secure WebSocket. And actually, in this case, we don't use tokens over the payload because it's more complex to configure, but we are passing our token on the URL. You can configure that differently. And the nice thing here is that you actually can now write middlewares that intercept all those things that the sockets do, and even write things like poly on top of it. Okay, so we set up our WebSockets client. So all the socketing is done. And if we look at our dependency injection configuration, we can actually see that we are generating a ton of code. We have now a socket connection pool where we pool the socket connection, so that we are using not too many. And there's a subscription manager. So all this will ensure that we are most of the times using just one connection to pass all the messages over. Okay. So let's just run this, because this is actually all we had to do. We had to write a GraphQL subscription in our query. We put that in. A Strawberry Shake just generated all the code for us, and we just had to tell our system how to connect to the WebSocket. Okay, it's built. Let's run it, and then go back into our demo here. So I could go on here, and I actually could scroll down here. And so let's send something in. There is an application. Let me just swap over to my slides. So let's try to open this. So you can actually call this website. And I will display it in a minute again. Let me debug it also, because maybe it doesn't work. We don't know. Let me grab that. It's just a simple site that will log you in as a user, and you can actually send in a message, and you can see hello world, that this is popping up. Oh, there's somebody else already writing in messages. So you can see it's super awesome how easy you can do real time, and you can see people are writing messages into just my debug session here, and even German messages. Okay, awesome. There's Zurich people. So with that, I'm pretty much done. You're load testing just my GraphQL server, and hello from Belgium. Hello. Okay, let's go back to our slides. I'll leave that running. And yeah, we did real time, and it wasn't that difficult. And if you grab Strawberry Shake, it's really an amazing tool, and there are a lot of contributors to it. So let me just point out that Raphael and Pascal are two contributors who do a lot great work on the project. Okay. So conclusion, with GraphQL and Blazor, we actually can iterate much faster, because with GraphQL, you, the consumer of the GraphQL API, you define the interface between the server and your application. And that means, depending on your application, you just write another GraphQL query up, GraphQL query document, and create a new server interface between your application and the server. Basically, the document that we wrote was our server interface that we defined. And with Blazor, we now can do .NET in the browser, meaning we can write everything in C#. And that actually lets us reuse the knowledge that we acquired in Windows applications, in WPF, in ASP.NET Core, and reuse that in the browser and write awesome applications. And it's not just our knowledge. We can reuse packages. We can use, you saw dependency injection. We just plugged it in. You saw that we used the HTTP client factory. We just plugged it in. Okay, and with GraphQL, we actually can fetch data more efficiently, since we define the interface between the server. So we just fetch what we need. And the best thing for me personally, because I'm rubbish at JavaScript, I'm not saying that JavaScript is actually rubbish, but I'm rubbish at JavaScript, and I feel quite home with C#. So for me, the greatest benefit is also that I can use C# to write browser applications. Finally, I'm a full stack developer. So let me give you just a simple, small outlook here. So Blazor and Strawberry Shake will release in May 2020. So we are aligning our release date with Blazor. So Blazor for WebAssembly releases then. And we are bringing with that awesome tooling. Like you saw already Strawberry Shake, but we are at the moment working on a very rich integration into Visual Studio. So you will have GraphQL, IntelliSense, code highlighting, and it will be a simple click, right click on the project tree, and you can say add GraphQL client, type in the details, and we generate everything that you need. It's actually a quite nice experience. I'm happy to show that off in May. But we are not done there, because there's gRPC, which is super efficient, and GraphQL actually is transport agnostic. So what we are also working on is putting GraphQL into gRPC, meaning you can basically do just your GraphQL like you did before, and then you have just another channel. You, instead of at HTTP, you do at gRPC, and everything is configured and uses then gRPC in the backend. I hope everybody is happy with the talk. It was my first time to do it in the kitchen, and it's quite a different experience. And you can grab all the information that I have given you here on chillicream.com. We have a blog there, and we actually have. You can also head to our repo. Everything that we are doing is open source. So go there if you want to contribute, even start contributing. And I will put all these slides online. I will share that with Irina, where I should put them, so you can get all the examples and all the slides if you want them. So I'm now open for questions. I don't know.
We have a Slido. Bogdan will share the screen.
Yeah, just a second, I'll share my screen. Yeah. Can you see them?
Yep.
Yes.
Okay.
So what's the ideal way of versioning GraphQL APIs? Not at all. Actually, that talk was just, I just did a very small introduction to GraphQL. In a real GraphQL talk, I would point that out, that GraphQL actually does away with versioning. It's more aligned with the way we are building APIs in .NET by deprecating fields that we don't need, and then tracking if the field usage drops, we would at one point remove that field. That would be my answer to that. How does GraphQL handle pagination? Yeah, I didn't show that, but we had actually in our API pagination endpoint, relay pagination already configured. So there are two ways to do pagination in GraphQL. The preferred method is called a cursor-based pagination. And that is basically by having an endless stream and being able to fetch the next page by using cursors. It's difficult to just explain it like that, but that is one way. The other way is by using offset pagination. But with hot chocolate actually, and you can just put in pagination middleware, and then we are automatically adding all the stuff to your GraphQL schema, and we are rewriting the GraphQL graph that, or the GraphQL query graph into native database queries. So you actually have to do almost nothing to get pagination done. What about startup times? Clients using WebAssembly? They are pretty good, but actually at the moment, the size is not optimal. So I think it was like 2 megabytes that you have to initially download for WebAssembly to run. So it's bigger than a React app, for instance. But the Microsoft team is actually working to get that size smaller. So at the moment, my recommendation would be regarding Blazor for WebAssembly. It's good for enterprise applications. But when they finally got the size down and make things like that, maybe they can stream the assemblies on demand, something like that, then it would be actually a very good solution even for websites. But at the moment, it's even in preview yet. I would consider it for enterprise application. That doesn't matter if you initially download 2 megabytes. I mean, you only download it once. But if that matters to you, then React is a great solution still to build applications. Okay, what would one consider the major advantages of using GraphQL instead of gRPC? Actually, I showed that. So you basically can consume what you want. You can do everything over one connection. And GraphQL is actually transport agnostic. So that's one thing I showed off at the end. We are basically building GraphQL over gRPC that we will release in August. So you will be able to use GraphQL over gRPC. It actually, GraphQL has a lot of other features, like there is things like, no, I forgot, like streaming APIs where you can define one request and then stream parts of the request, so you get them over chunked encoding later. So there's a lot to GraphQL, and I wouldn't say these things are exclusive. So you could use gRPC and GraphQL, or you use GraphQL over gRPC, or you could even use GraphQL over TCP sockets if you want to, or over WebSockets. We are supporting that already. So how does GraphQL handle pagination? We had that. Is Banana Cake Pop open source? Is it made by forking VS Code or something? So Banana Cake Pop is still in early preview. We use Monaco at its core, but all the IntelliSense is actually built by us. So it's not using anything graphical or something like this. Graphical themselves are switching to Monaco. So they are doing a lot of great work there. But when we started on Banana Cake Pop, graphical actually was still using something else, forgot it now. And so we built that all on Monaco. It is not yet open source because we think it's not good enough yet. Although it's my favorite GraphQL IDE already, you can download it already for free. And at one point, we are putting it in the monorepo that we have. So you can already see the folder, but we haven't pushed that commit yet, but it will be. Would it be possible to share a repo with the demo examples? Yes, it will. I will give Irina all the links and she will post them, I think. How are you testing the UI? Are there libraries that can be used to test Blazor output? Yeah, Microsoft is building a lot around that. I think Daniel Roth said there is a lot of testing stuff coming, and there are also open source projects to do that. So I haven't looked into that yet. I'm at the moment more concerned how we can do data mining, and what you saw just yet is just the client generator. We're also building at the moment something like we are building a store around it so basically to do stuff like Relay is doing for React. So there's a lot of more work coming towards Strawberry Shake. Is there a possibility with Blazor to implement micro frontends using shared process, or can it be multi-process? I honestly don't know. I would have to myself ask people about that. So there might be, I mean, you can build components, but the cool, so you can componentize a Blazor. But the question there would be for me, could we somehow stream these components only if they need it. Like Relay is doing awesome work in React, where actually they are combining the components with the data. And you basically can annotate your GraphQL queries with components so that when you need some data, it also loads the components together. So you never have to load all the components when your application starts up, but only when you're fetching the right data. So they're doing a lot of awesome work at Facebook, and it would be awesome if Blazor could do that too, but I don't know how far they are there. Is it possible to have the GraphQL files segmented and stitch them? That's a good question. Actually, the GraphQL generator works on top of our schema stitching engine, and our idea around that is that you can locally stitch data. It is not as efficient that you can locally stitch schemas. It is actually not as efficient as having a stitched server in the backend, but there are situations where you have your company GraphQL server and you might want to use the GitHub GraphQL server as well. And then we allow them to allow you to stitch them together locally. So you have locally one data graph that consists of the GitHub GraphQL schema and other GraphQL and your company GraphQL schema. But you can do even more. And there was not enough time in this talk. But we allow you to rewrite the local types. So you can say, I have a local type, and that local type should be stored somewhere on my disk or stuff like that. So there's a lot more possible. So yes, you can do that. And do you think Blazor is ready for production? And just yet, especially when considering tooling, download size, etc. So if you ask me, is Blazor ready for production today? Depends on what Blazor you mean. Like Blazor for the Blazor server is ready for production. Microsoft actually proved that it works, and they proved that it works with massive loads. If you ask me for what I showed you, Blazor for WebAssembly, it's not ready yet because it's still preview. So everything I showed you is preview. But I'm sure Microsoft will get it there in May. But I still think it's not ready for every scenario. And if your company, for instance, is heavily invested in React and has the people that can do it, then there is no reason to switch. But I think over the next 1 or 2 years, this will become really a driving force. And for enterprise applications, I think already it will be super awesome in May. But there is also a still of components that you need to write. So the component ecosystem in React is just so much bigger at the moment. But Microsoft is doing a good job around that. So it depends is my answer. How Blazor will improve Electron? The problem with Electron is you need to carry. So I think the way to improve Electron is actually to drop Electron. And Sanderson actually says that he's experimenting with native web views. So that they're basically not using Electron at all, but just using the web view of the operating system. And each operating system nowadays has such a web view. And this way you would have just the payload of your DLLs that you put there. So it would be much reduced and you have not all this memory overhead. So I think it's quite an awesome approach, but that is experimental. So they haven't committed to shipping that actually. So they're experimenting on that. Great.
I think that's it.
Yeah.
No more questions.
There is a feedback form there because we really want to emphasize the feedback, its importance. Thank you, Michael, for doing this. We really enjoyed it. So I hope you enjoyed it also.
Yeah, it was a little bit quiet.
And
here in the kitchen,
we
but-
should we should do this more often, I think.
Yeah, it was a great thing.
So see you
For
next
everybody,
time.
yeah, just follow our pages because we'll post the links that
Ah, yes.
Yes,
Just let me post you.
Yeah,
the,
no problem. We'll share them everywhere after that, so there's no
Yep.
rush.
yeah.
Bye, guys. Enjoy
bye,
the
guys.
weekend.
Bye.
Awesome. Goodbye.